Good evening to everyone. Myself, P. Vanitha, working as an assistant professor in the Department of Electrical and Electronics Engineering. In this session, we are going to discuss how high AC currents and high AC voltage are measured safely. When we measure small currents, we can directly use an ammeter. Similarly, for small voltages, we use a voltmeter. For measuring high AC current, sometimes a low range AC ammeter is connected with a shunt resistor. For measuring high AC voltage, a low range voltmeter is connected with a high value series resistor. But these methods are not suitable for extremely high current and voltages. Why? Because the instruments may get damaged due to excessive current or voltage. So in such cases, we use special devices called instrument transformers. Uh, Instrument transformers provides electrical isolation between high voltage power circuits and the measuring instruments. This isolation protects the measuring instruments and also ensures safety of the operator. The instruments transformers are classified into two types: current transformers and potential transformers. Uh, Now let us discuss the current transformer. Commonly, it is called as C2. The current transformer is used to measure high AC current. Uh, Here, the current transformer circuit diagram is shown in figure, and the actual current transformer picture is also attached here. The primary winding of a current transformer is composed of one or more turns of thick wire, which is connected, in series with the electrical line carrying the current to the measure. The secondary winding contains many turns of fine wire and is linked to an ammeter or the input terminals of a relay for current measurement or control purposes. This is the construction types of current transformers. Window type and bar type, the switches are attached to. The primary winding of a sieve consists of one or very few turns of thick wire. The primary winding is connected in series with the line carrying the current to be measured. The secondary winding has many turns of the fine wire. The secondary winding is connected to an ammeter or the productive unit. So basically, primary winding carries high current and secondary winding carries reduced current. The main purpose is to reduce high current to a small measurable value. Now let us understand the working principle of a current transformer. The CT works on the principle of electromagnetic induction. When AC currents, AC current flows in the primary winding, it produces magnetic flux. This magnetic flux induces current in the secondary winding. The secondary current is proportional to the primary current. The ratio between primary current and secondary current is called CT ratio. For example, if the CT ratio is 100 by 5, that means when 100 amperes flow in the primary, 5 amperes flow in the secondary. So if the ammeter connected to the secondary shows 4 amperes. Actual primary current equal to CT ratio into ammeter reading. That is equal to 100 by 5 into 4. Uh, it is 80 amperes. So CT helps us measure high currents safely. Uh, the important precaution of the CT is the secondary of the CT should never be left open while primary is energized. If it is left open, Very high voltage may be induced in the secondary, which can damage the insulation and cause danger. Now let us move to the potential transformer, commonly called PT. The potential transformer is used to measure high AC voltage. It is basically a step-down transformer. Here the PT construction diagram is shown in figure. The primary winding has a large number of turns. The secondary winding has fewer turns. The primary is connected in parallel with the high voltage line. A voltmeter is connected to the secondary winding. Usually, 150 voltmeter is used. Next, we will move on the operation of PT. When high voltage is applied to the primary side, a reduced voltage appears at the secondary winding. The voltmeter shows the reduced value only. To find actual line voltage, the formula is line voltage equal to voltmeter read is divided by transformation ratio. Where the transformation ratio is equal to V2 divided by V1. So PT reduces high voltage to a safe measurable level. Now let us see important precautions of potential transformer. The secondary winding must be fully insulated from the high voltage primary. For safety, the secondary should be grounded. The secondary winding ratings is usually between 40 to 100 watts because it may supply relays and meters. If proper insulation and grounding are not provided, there may be a serious electrical hazards. So safety is very important when using instrument transformers. Here, let us see the type of potential transformers. Some types are cell type, dry type, and oil types. For the rating is below 5000 volt. It is called cell type transformer, potential transformer. The rating is 5000 to 13,800 volt. It is called a dry type and oil type potential transformers. The above 13,800 volt is called only oil type potential transformers. Now let us discuss Megger. A Megger is an instrument used to measure insulation resistance. It is mainly used to check insulation of cables, motors, and electrical equipment. There are uh, two types of measures are there. First one is hand crank measure. The second one is electronic measure. In hand crank measure, the test voltage is generated by rotating electrons. In electronic measure, uh, battery in electronic measure, the battery is used to generate test voltage. For equipment rated up to 400 volts, the 500 volt DC test is usually sufficient. For high voltage systems, test voltage ranges from 1000 to 5000 volts. The measure works on the principle of electromagnetic induction principle. It generates DC voltage and measures insulation resistance. Here the construction of measure diagram is shown in here. So today we discussed measurement of high AC current and voltage, current transformer and its working, potential transformers and its working, safety precautions, ledger for insulation testing. Uh, Instrument transformers are very important for safe and accurate measurement in high voltage systems. Without CT and PT, measuring high power quantities would be dangerous. Understanding these concepts is very important for power system and protection studies. Thank you.